In this video, we're going to be looking at perpendicular bisectors and midpoints. So first of all, we're going to find the midpoint first. So let's say I have a point here and a point here, and I want to find the midpoint of the 2 points, this middle one here. So let's just call this coordinate x1, y1, this coordinate x2, y2. So to find the midpoint, it's actually just the sum of each axis, so x1 plus x2 divided by 2, comma y1 plus y2 divided by 2, like this. So it's just very simple. As long as you know the two coordinates, then you can find the midpoint. Right, moving on, we can also find something called a perpendicular bisector. So we know that perpendicular, we learned in the previous one, is when two lines are at right angles to each other at 90 degrees. So technically all these lines are perpendicular to the original black line here because they're all 90 degrees. But a perpendicular bisector, the word bisector just means in half or bisect in half, right? So they're asking for you to find a specific perpendicular bisector. And so if I draw a line here, the perpendicular bisector would be the line which is perpendicular, but it goes through the midpoint of the 2 points either side of it. So that's called A and B. So this perpendicular bisector will be the one that's 90 degrees and goes through the midpoints of A and B. So it's a very specific line relative to A and B. Right, so let's use this knowledge to answer this question here. So the line JK is the diameter of the circle P, where J and K are 0, -3 and 4, -5. So first to just sketch it quickly. So 0, -3 and then 4, -5, like this. Okay, so this here is J and this here is K. And they are the diameters of the circle. So if I was to draw a circle, looks something like so. Okay. The line L passes through P, where P is the circle center. So P is the midpoint here, which is circle center, and it's perpendicular to J and K. So it's going to be this line here. Find the equation of L. So what you should realize is that first of all, the P line is perpendicular, and it's also a perpendicular bisector because it passes through the middle of the 2 points J and K. So we're asked to find this point here. So first things first, we need to find the gradient, right? Because all straight lines, you start off with the gradient. We're given the coordinates of J and K, so we can find the gradient of P because they're perpendicular, so we can just use the relationship -1 over, right? So let's find the gradient of J and K first. So it's going to be changing y, we're changing x, so -5 minus -3 over 4 minus 0. So we get -2 over 4, so -1 over 2 is the gradient from J to K. So therefore the gradient of M, of P, right, MP would be -1 over the gradient of J to K, so -1 over 2, so it'll just be 2. So we know that y is 2x plus c. Now we have to find the c value, but in order to find the c value, we need to find the p value. We need to know where the midpoint is. So we also need to work out the midpoint equation, or the midpoint, using the equation we learned earlier. So sum of x's, so 0 plus 4 over 2, comma sum of y's, -3 plus -5 over 2. This will give us the midpoint and the coordinate of p. So this is going to be 2, -4. So now I can plug this into this equation to find c, right? So -4 is equal to 2 times 2 plus c. C is going to be equal to -8. So the equation will be 2x minus 8. So this is going to be the perpendicular bisector equation of J to K.